This conference will now be recorded.
Perfect. I think I can now start. Well, good afternoon, everybody, and thank you for coming along today to listen to the paper on say turning today's waste into tomorrow's track infrastructure. And thank you, Phil, for the introduction. My name, as I say, is William Mainwaring, and I come from a company called Cycad Enterprises Limited, and we are the manufacturer and supplier of composite materials made from recycled polymers. Primarily railway sleepers and S&C bearers for use in the track infrastructure. So whilst today's talk will be focused on the railway sleeper, the opportunity to use recycled and waste materials in applications within track are broader than that, and I'm happy to answer and talk about other alternative applications for this at the end of the presentation. The agenda today I've set out here, so I'll look a little bit first at the drivers for change within that are leading to greater use of novel materials in track. I'll be a little bit focused on Network Rail, because they've taken quite a lead on this over recent months, but they were preceded in that by an awful lot of work done by Transport for London, and Howard Russell's attending today and has been actively involved in that for a number of years. So I think can take a lot of credit for where we are today. I'll then introduce the Cycad composite sleeper and provide that example setting into that context, and look at how these materials can deliver performance value and sustainability against those different targets that are set out. I'll then look a little bit around installation, handling and maintenance to look at some of those more practical questions before looking at some of the advantages of these materials against hardwood, concrete and steel alternatives. And I'll finish with just some thoughts on continued innovation that is happening, and then look at just a couple of example projects in there to set that into some context. And there'll be an opportunity for questions, as Phil has mentioned, at the end. But please do feel free to sort of add questions into the chats as we go along. So looking at first those drivers for change, and there are a number of them, and the first one, which is really been around health and safety, and the use of creosote in the railway track infrastructure. Creosote's been used as a preservative for softwood and hardwood around the world for many decades. But it is in itself a carcinogenic material and a toxic substance, both hazardous to human health and to that in the environment. And because of that, there has been in fact a European ban on the use of creosote since 2003, and that ban has been extended in two applications, railway sleepers being one and the other being telegraph poles, since that period of time. But those bans are now coming into effect more formally within European countries, and the UK is one of those that is fully adopting that ban and certainly Network Rail within the track infrastructure. And Network Rail ceased procuring softwood sleepers treated with creosote from the 31st of July last year on that front, and that effect is then being seen across Europe as well, as those sort of factors around health and safety become important. The second one, and it's linked into the broader picture around the environment and sustainability, and this is clearly a topic under regular discussion across all different aspects of life, and the rail environment is no exception. And Network Rail published their own strategy for the environment and sustainability, and they call it the Network Rail Environment and Sustainability Strategy 2050, and that set out some broad and pretty clear targets for sustainability, the use of recycled materials and recycling of materials used in the infrastructure within that. It has also been worked and calculated by Network Rail and others that the railway sleepers are the second highest embodied carbon material in the track infrastructure, and also that the use of hardwood, which is sourced mainly from Brazil in the UK, but also steel and concrete, are high embodied carbon factors, and that there are now increasingly more proven alternatives that can be used to reduce embodied carbon in the infrastructure. And that, of course, is separate from all the work that's being done on rolling stock and use of energy and electrification, etc. Within that piece. So a big driver for change being the environment. And also value. Value has been talked about, and this is whole life value within the infrastructure. It's been talked about for many years. Cost has still been the driving function for those many years, but that requirement for asset sustainability is now rising to the further up the agenda, particularly within organisations such as Network Rail. And the Office for Rail Responsibility has, of one of its 4 priorities for the next Network Rail control period, has been to ensure that the assets are planned and managed to deliver the greatest value over the course of their operational lives, and to focus on that value piece rather than focusing on cost within that context. And that is changing the way track design is being looked at into the future. And more recent impacts around decision making of material procurement has been driven through COP26, and where we saw well publicised the UK and most other countries around the world made a commitment to reverse deforestation. And as I mentioned, Network Rail sources most of its hardwood sleepers from Brazil. And with 2.5 acres of tropical hardwood forest required per mile of track, there is a substantial impact on track infrastructure through that. And looking at the average life of hardwood timber being less than 20 years, with the time for that hardwood to grow in those rainforests being much greater than 100 years, the continued use of timber in the track infrastructure is not sustainable. So a key range of drivers looking at change. Network Rail, and I said I'd focus a little on Network Rail, look to develop a broader strategy around the use of novel materials in track, and they called it the Composites Materials in Track strategy for asset enhancement. And this was a broad strategy that's been developed over the last 5 or 6 years within Network Rail, and looking at identifying alternative materials for use within infrastructure. It wasn't just development within the UK with Network Rail, but also internationally through the development of new standards for new materials to sit alongside the standards for concrete, timber and steel materials in track at the moment. And there is now a new ISO standard for polymer composite railway sleepers, bearers and transoms within the market for evaluation. And through that strategy, Network Rail has also developed, as have TfL, and that developed their own standards for composite materials in track. And for Network Rail, it's the L2 track 039 standard, and for TfL, it's the technical standard 0348 for composite materials. And that has enabled a greater understanding of the different technologies and products out in the market to be evaluated. And this led to a tender being run by Network Rail 18 months or so ago, and led to a framework agreement for the supply of polymer composite sleepers into Network Rail. And my company, Syca, was the company that won that contract, and hence, well, I'll be exploring that and our product a little bit more in there. So, as you can see from the composites and materials track strategy that's shown there in the bottom left-hand corner of the slide, Network Rail are well through that. They're well into their good practice phase of that, and looking now to move forward into a phase where plastic composites, particularly those made from recycled materials, can become the norm in the fabrication of the track infrastructure as an alternative to other sleeper type materials. So, looking a bit more specifically into the Syca composite sleeper, which is the product that we supply. The Syca composite sleeper is manufactured here in the UK, actually up in the northeast of England, and it's made almost entirely from waste plastic materials. It's reinforced by waste glass fibre, and at end of life, the products are either reusable and they can be reusable back in track, but they're also 100% recyclable at the end of life, to remove any future liabilities in that context. They're not a new product. They're fully developed at TRL 9, and they've been installed in Europe, right across Europe since 2013, and they've been installed in the US actually much before that, actually since 1996. And they have full TSI certification for use within the European Rail Network, up to category C, which is a NR-Cat 2 track, but have been used in all categories of track other than Cat 1A really in Europe, and they've been in the US in heavy haul track up to 35-ton axle loads, and of course they've been extensively used around public transport systems as well. In Europe, the product has full Deutsche Bahn approval, and that was after a 5-year lab and track trial by Deutsche Bahn. They have full approval in Sweden, having had the same, well, having had track trials with Trafikverket since 2016. And as I mentioned, they're also fully compliant with the US ARIMA Chapter 30 to 35-ton axle loads for the heavy haul heavy haul networks in North America. And as I mentioned earlier, there was a competitive tender which Cycat won in 2019, and we're now the sole supplier of composite sleepers to Network Rail. They are available on Enroll now, and can be supplied either plain sleepers, drilled, or fully plated, as shown actually in the example in the picture on the left, which is in the Wales route. Going back to these sort of key focuses of performance and value and sustainability, the performance has been proven in the laboratory and in track to international, European, and US standards. Actually, there's an extraordinary amount of testing that has been done, really to test not only the product but the concept of composite sleepers as alternatives to concrete and wood, and understanding that wood and concrete perform in very different ways, but they perform the same function. There's been a tremendous amount of analysis that's been done through the various European and international committees into these new technologies. With closer to home, separate to the fairly detailed evaluation by TfL back in sort of 2014, 2015, Network Rail have taken the product through the full design for reliability process, as well as the system safety processes through CSM, leading through to product acceptance with Network Rail. But we've worked with all of the major national rail organisations around Europe over the last 5 or 6 years. And as a result, we're fully approved for European mainline track through that independent testing, and fully certified, which gives confidence and has given confidence to rail operators more broadly in use of the material in a range of different applications. Testing in terms of the system performance testing, so working with a range of different fixing systems. Again, it's been tested to the same standards that are used to test concrete and timber sleepers with both plates, and they've been tested up to category E, which is a 30-ton axle load in Europe. An awful lot of use in the depots and public transport through that. TfL were the earliest adopter in Europe on a public transport network, and we have had full approval with TfL since 2015. And as Howard will tell you, we've supplied many thousands of sleepers and SSC bearers into TfL over the last few years. We've also supplied all of the sleepers and SSC bearers into the DLR Beckton depot project, and that was after a change of spec from concrete sleepers over that, and that was a balance of looking at the value delivered as well as the improvements to the project delivery, which is underway as we speak. And outside of the UK, we've expanded extensively across Europe to networks from Hamburg in Germany, Berlin, Vienna, Barcelona, Milan, so across a range of different countries there as well. And also working with Howard and at Lilliebridge and with TfL, we've also developed jointing plate systems for cyclic bearers so that we can deliver long bearers of over 8 meters in length to provide for different and more complex project areas as well. So moving on to the question of value. And as we've mentioned, the ORR driving this sort of asset delivery to deliver operational value over life. And there has been a tremendous amount of analysis conducted on and whole life modelling conducted by rail operators and Network Rail and TfL, and no exception to that. And Network Rail have calculated that through reduced maintenance and much longer life and greater durability, they could see as much as nearly £3,000 worth of saving per composite sleeper installed in comparison to the continued use of hardwood materials. So there are big savings to be delivered over life through use of these more modern materials, and even against concrete sleepers. Savings of substantial savings have also been calculated through that. And when one sort of racks that up and looks at numbers into CP7 just for the timber sleeper replacement, over a 50-year asset life, savings of 800 or so million have been calculated by Network Rail. So these are meaningful numbers in terms of value saving over the life of the asset. And then against the environment, the use, and we've mentioned about the sleepers being a very high component of the embodied carbon in the track infrastructure. The use of materials, and particularly recycled materials, such as the cyclic composite sleeper, will deliver very substantial savings in carbon footprint compared to either a G44 concrete or untreated hardwood sleepers or steel, as the graph on the right shows. But looking at perhaps 120 to 400,000 kilograms of CO2 per kilometre savings, and so these are meaningful and support both the environmental strategies for Network Rail and work around past 2080, which is about demonstrating performance or demonstrating carbon savings within infrastructure as well as through energy savings. And that's where these numbers come from. When you look at the embodied carbon within different sleeper types, you can see there the use of recycled materials in there, even utilising base plates, delivers very substantial savings through that. And these numbers get backed up by environmental product declarations as necessary to support that. But separate to that simple question about carbon savings, there's an increasing requirement in all construction projects, rail and others, to look at delivering against the principles of the circular economy. So looking at what happens to products right through their life and at end of life. Here and much of the circular economy that we read about is based around perhaps trying to convert your old milk bottle back into a new milk bottle and whiz it around that cycle. And there are targets that have been placed on the manufacturer of bottles, or whether it's Procter & Gamble or Unilever, to deliver 30% recycled content in their next round of bottles. The major problem with that philosophy is that the materials move so quickly around that cycle, and they're only in use for such a relatively short period of time. Combined with the one downside of recycling plastics is you can only do it a certain number of times before the material degrades. You are always limited by the recycled content in a new bottle, which is why the target is set at 30%, not 90%. When you start looking at different products, and so you start looking at taking a milk bottle and turning it into something else, and in this case, an infrastructure product, such as a railway sleeper, you're then putting it into a product in that cycle that has a useful life of decades, not weeks. And then the cycle starts to make sense. And because you're looking at a product that has very different performance properties, you can put 100% recycled material into that product, and you can take many thousand milk bottles to make into a railway sleeper and then have it usefully employed for many decades. And then after it's been used in that application, it can be redeployed into a different application. In this picture, we show a railway sleeper then being used as a back of wall timber on a railway bridge, but there are many others, before ultimately it can be recycled back into a new product again. So you get this very long cycle, not a short one. And contrary to Boris's comment that plastic recycling doesn't work the other day, this is a circular economy that really does. Because it makes very useful application of waste materials in a very welcome way, and of course it does that while providing an opportunity to play an important role in addressing that proliferation of plastic waste, of which we are only too aware through the media. So it's a valuable use of recycled plastic materials. And so it represents plastic recycling that really works. And it's essentially an open to closed loop model, and it takes post-consumer products and uses them in an industrial application for many decades. And that gives you a bit of an idea of what a kilometre of railway track would make use of. It's over 6 million waste plastic bottles per kilometre of track. So it's a proper and meaningful contribution to that. But also looking at these, you're looking to support the targets to reverse deforestation. So as well as making useful use of that waste plastics, you're saving the removal of 2.5 acres of tropical rainforest per kilometre, and the use of timber in track is simply not sustainable into the future. So that's looking at the drivers, and looking a little bit then, because the other aspect of all of these things is these new products into track. They need to be simple to install, they need to be easy to handle, they need to be easy to maintain, ideally without requiring a great deal of extra training involved with them as well. There is now, we have our own guide for these materials, but Network Rail have developed its own TWI for handling of composite materials in track as well, and that's the TWI for reference for those that are interested. And there have also been, various amounts of work done by organisations such as TfL around the safe handling and use of the materials. Work's been done with the ergonomics team at Network Rail and with TfL to look at use of existing manual handling equipment, so concrete and timber nips, for example, which have both been approved for use in handling the product, separate from all the range of mechanical handling equipments that are available to do that as well. In terms of handling in comparison to timber, if one thinks of these materials as as timber materials but not, so utilizing the same equipment for drilling and for fixing as you would in timber. Chambray have actually developed a fitting for their battery operated drill that is more effective than the one designed for timber, but it uses the same base equipment and the same drill bit to achieve that. But it drills and fixes in a very simple and the same way. Lots of work and evaluation done around this, around all those processes, so rail welding and grinding, use of different welding equipments that can be used on track, whether it's hand or thermite welding of the same processes and procedures that will be used for welding in timber or concrete track can be used safely and effectively as well. Lots of questions there always about around how one fixes, and errors and mistakes get made in fixing down to sleepers, and the use of spike fast, which is commonly used for the repair of timber sleepers, has been approved for use with the composite sleepers as well. So that there again no need for different training or different practices or approaches or materials for conducting that work. Assessment with the use of mechanical tamping is obviously important, with a range of different tamping equipments in use. The left hand two obviously for the ones used in the UK, and the top right actually similar equipment but used in Germany. The effect of tamper strike has also been monitored, both using the Balfour Beatty tamping equipment at the top left, as well as the track mounted equipment in the bottom left. And it's been shown that tamper strikes don't cause damage that to the sleepers that needs replacement. And in fact, that's been monitored, and that was done by Deutsche Bahn as well, to look at monitoring long-term effects of tamper strikes on composite sleepers over a 5-year period. And no long-term damage was seen, or not a long-term effect was seen of those as well. So again, no need for changing of approaches used for other material types. And also high output delivery. So this has been evaluated in Europe, and this is actually this is OBB in Austria, shown here in the images. And there's a high output trial with both the Network Rail high output capability and the BAFBID NCT machine happening this week, this Thursday, for the use of that. And again, there's no perceived issues with that for use in the UK out of high output. And as you'll see a little bit later on, there's been fast clip base plate developments working with Pandrol, so that you can have common clipping through the different sleeper types through high output. So looking at a little bit, and we've talked about some of the advantages of composites as we've gone through, particularly environmentally. And the key advantages over hardwood really relate to, separate to environment, they relate to durability. So the composite materials, do not rot or degrade during their use in the infrastructure. And because they don't rot and degrade, and because they are so durable, they can handle some pretty poor ballast conditions. And that's one example of not amongst the worst actually in the UK on that piece. And of course, through reduced, with a long service life, you've got reduced disruptive possessions necessary for renewals or for maintenance, which increases capacity, and of course it keeps the operators and manpower off the infrastructure, which is safer. And when we're back and comparing with creosote, which is one of the key drivers for Network Rail, you've got a product of similar weight to a softwood sleeper that sits between a soft and hardwood sleeper, but you haven't got any risk associated with handling of creosote on those pieces as well. And we've mentioned the tamper damage piece already. Against concrete, the arguments are different, but actually there are perhaps more benefits against concrete, again around manual handling, durability, and particularly in those poor ballast conditions in there. But you've also got the flexibility that you get with timber sleepers, so ease of on-site drilling, easy fixing for signaling and EMP equipment to that. You've got very strong resistance to electrical conductivity for that regard as well. Products can be short-ended, chamfered, again resistance to the tamper strikes in there. So there are a lot of advantages associated with the use of composite sleepers for their durability. And they're also easy to use with various different configurations, and this is an example of a viaduct project which received quite a lot of publicity, but again, requirement for guardrails. So fixing guardrails is just a standard product for fixing guardrails inside or outside of the gauge. And because of their lightweight, it offers greater opportunities for prefabrication of large panel components as well. And again, to lead to faster installation on site and reducing installation risk within that, but also reducing the handling and transport side of that too. And being reduced weight, and particularly against concrete, then you can be looking at some 16 fewer deliveries perhaps if one's delivering by road per kilometre just for the sleepers in those types of installations. And this has become it's a particularly important factor for projects like Beckton with greatly restricted opportunities for delivery into a restricted urban location. And you can see in that bottom left picture, because those were going into King's Cross, actually you can see short-ended and chamfered sleepers there on the train going into that project. So a lot of prefabrication work done to fit in with very tight installation envelopes. And the other aspect of these compared to concrete, because of their reduced height in that context, there's a reduction in the need for crib ballast. It's about 33% less crib ballast used in the composite sleeper track compared to concrete. So it's about 400 tons less ballast per kilometre plus the logistics savings associated with that as well. And against steel, beyond the big carbon saving that's delivered against steel, they're ideal for spot replacement into timber track, suited for track conditions, as we've talked before. They work well, and they deliver good lateral resistance, very good lateral resistance on their own, but they're also suited to LRP if that's required for tight radius curves, and can be used with any base plate design, including garden check rail base plates that might be designed for timber. And then of course we've got the working well within the third rail and the EMP applications that we've talked about previously. And looking then a bit forward into other innovation that is going on in this space, I've mentioned fast clip and the use of fast clip on composite sleepers. So there is now an approved, it's going through its final PA with Network Rail, but fully tested fast clip base plate developed by Pandrol for use on the composite sleeper, and that's already in track. Actually, that's already in track in Cat 2 for evaluation, and that is also going through the high output equipment later this week. And that's suitable, as with the G44, it's suitable for both 60 E2 and 56 E1 rail profiles in those applications. And then also looking at other more challenging applications. So in bridges, particularly, looking where issues issues may be presented around height variation, ability to adjust gauge without re-drilling on site. So looking at developing systems that enable that to happen. And again, we've done a lot of work actually on this with Pandrol to develop plating systems that provide both lateral adjustments within the plate, but also height adjustment. And you can see in the image on the right, that's a plate undergoing the testing to 13481 with 100 millimeters of height variation above the sleeper with a through bolted system. So standard product can be supplied to site, and fine adjustments made on site with the use of shims, as you've shown there. But that's a sort of huge range of height variation through the sleeper. And then the image on the left is a project actually for Adif in Spain on a bridge where they wanted to be able to see some lateral variation and height variation on bridging sleepers through a complex bridging project in Spain. So just finishing now, just on a couple of examples, and I have picked Network Rail examples, but there are many more that have been done recently. So this is King's Cross in the remodelling project there through the boards in the gasworks tunnel, and these sleepers are short-ended and chamfered to reflect the very tight profile of the tunnel, as you can see on the outer side there, and that was with Eastern. This was a project, to say, in the Wales network, and it was spot replacing in a whole range. So this part of Wales adopts a strategy of replacing all those sleepers that need replacing. So you had 1 in 3s, but you also had sections of wet bed track that had several sleepers replaced in that piece. As going through, they were looking at different methods of mechanical installation. So in this case, because they had the space, they were looking at this mechanical installation approach to reduce manual handling and to improve safety. This is a project that received a lot of attention in the Wessex routes at Sherrington for the Viaduct project there. All prefabricated and the panels delivered down by train and installed on site over a weekend possession, and again utilising guardrails across the viaduct. And in this particular project, you've got concrete sleeper track running into the viaduct, but there wasn't the ballast depth to run concrete, or the strength in the structure to run concrete over the bridge. So the composite provided the same longevity, more longevity in use, but a much lighter weight and lower profile for that particular project. And here's another, and this is a project in the northwest route. Again, spot replacement, but using rail-mounted equipment to do this as well, both for installation and for tamping, as you can see. So a whole range of different uses and applications, and using standard equipment with the very minimum of additional training. In fact, for most, no need for additional training in those pieces as well. So in summary, the use of composites is growing. It's not new. There are standards that have been now developed, ISO and European as well, and local national standards for composite materials to be used in track in a range of different track categories as alternatives for hardwood, concrete, and steel. Sleepers are one of those. There are also the standards also apply to S&C bearers and to longitudinal timbers, and use of composites in other areas. And I've mentioned one in back of wall timbers as an example, but ballast retention, cable ducting, or others. So there's a broad opportunity for composites to be used. And because there's the ability with certain technologies to use recycled materials in those, there's the ability to deliver big carbon savings through that as well. And then through these materials that last substantially longer, require less routine maintenance on them in that piece, you can see whole life project costs of north of 4.4 million pounds per kilometre associated with that, that maintenance reduction and less frequent renewal. Carbon savings of maybe 400,000 kilograms of CO2 per kilometre to support those challenging environmental targets. And effective use of waste plastic bottles, which it's a challenge all around the world. But that's a lot of bottles per kilometre in these types of products, as well as reducing some logistic movements around those where it is necessary. And then through lower weight, more prefabrication, no use of hazardous treatment materials, offering improvements to health and safety through that as well as supporting COP26 targets to reverse deforestation. And then importantly, looking much longer into the future, these materials, because they can be reused and recycled, provide a very effective elimination of future liabilities associated with disposal at end of life. So I hope that provides you with some food for thought around our use of materials and how we can take our waste today and turn that into something really useful into the future within the track infrastructure. And I would, of course, be delighted to answer any questions that you may have.
Thanks very much, William. Can you hear me? Is that right? Yeah.
Yeah, I can hear you, absolutely.
Yeah. Okay, thanks. Yeah, thanks very much, William. It looks like we've got one question in the chat from Philip Holman, which says, what's the lead time for non-NR purchases? And does the order size make a difference? Because he says he's considering these for a project where only need only 8 to replace timbers over a single culvert. So yeah.
So thanks, Philip. I mean, the lead times for products are, it's like all things, it's a bit of a movable beast. We do hold, as Howard will attest, we do hold quite a decent inventory on the whole of material, but it will of course depend on the on the particular time an order is placed. So if 8 timbers are required for a culvert, they're probably in they'll almost certainly be in stock and can be delivered at pretty short notice. I don't think, whilst we have given lead times to Howard and to TfL and to Network Rail, we've yet to receive a single order that has stuck to those lead times. So far, so good, but I can't always promise that's going to be the case. And then just you've asked a question there, Philip, as well. I noticed on the fire resistance to there for use in tunnels. There's a slightly different question for how TfL look at this and how Network Rail. So we've done a full evaluation actually with Network Rail of this as part of the current process, and the fire performance for these actually is showing to be a little better than it is for a hardwood timber. Certainly with the heat release in a large fire scenario in that. So and you'll see that the sleepers have been installed in the King's Cross tunnel there. The evaluation has been done really in respect to that project. So obviously a sensitive site from that perspective. And I think the Eastern team and Network Rail are content with the fire performance with that regard. With respect to TfL, because TfL at the moment have a sort of what's become a zero sort of tolerance to any material that isn't meeting completely non-combustible requirements. TfL have yet to grant an approval for use subsurface in tunnels, although that is being reviewed into the future with respect to a project by project risk assessments. We're also working on a project with TfL for replacing pit blocks in the subsurface, and agreeing an approach to do that with the fire officer and fire officers within TfL. So I hope that gives you some answer, but happy to expand more on that if you wish.
Okay, thanks. Yeah, so I've got a question, or a couple of questions myself, William. One is first, I didn't see it mentioned, maybe I missed it, about the application of the this material to longitudinal timbers on bridges.
Yes, so the focus of SAC has been on crossing timbers. The longitudinals can certainly be used, and at the moment Network Rail is contracting with a Japanese company called Sekisui, and they have a product called FFU, and so that is the product that Network Rail are using as a hardwood alternative for longitudinals. And it's also been trial tested and approved, I think, by TfL. I would be able to confirm that as well. So that is a slightly different material. It's made from polyurethane and glass fiber. It performs extremely well in those applications. It doesn't offer the environmental savings that the cyclic material does, for example, because it's made of a virgin material and a virgin glass fiber. But it does offer all the benefits of longevity, use, lower maintenance in those applications, and of course substitutes for the use of tropical timbers in those applications.
Yeah, because I think the FFU, isn't it the case when you're installing FFU, there's a lot of PPE required.
It is, yes.
And I just wonder if comparisons to your working with your product, there is less of a need.
Yeah.
Yeah,
no requirement at all for additional PPE with working with the cyclic product. So the reason that with FFU one needs to wear extra PPE is when it's drilled or cut on site. If that is part of the the delivery model on a project, then it creates a lot of dust, and the dust is a polyurethane and glass fiber dust, which is a hazardous dust. And that's why there's a requirement to wear, and often the requirements to wear full, well, certainly full breathing apparatus, but also coveralls to protect the clothing on that piece as well. So those requirements are not necessary with cyclic material because it's a thermoplastic, recycled thermoplastic with glass fiber, and as you drill it or cut it, you create essentially a swarf, and it's not an airborne dust. And actually, Howard can answer these probably quite. A lot of work's been done on this in looking at specific assessments of this in the workshops at Lillie Bridge with respect to health and safety, and teams not to require any extra protection.
Yeah, so I think it's an advantage. Yeah, okay, that's great. Yeah.
Phil's asked another question here.
Yeah. Yeah, I think it's
this is looking at long
split bearers. Yeah, sorry, go on.
Yeah, long sweepers that could be supplied for S&C with a single unit or with connectors, and if connects with bolts, etc. How does the connection compare to the ones currently used on long concrete bearers, which have a few issues? So there are two different designs for connecting bearers together. One, and the one that's been adopted by TfL, is actually extremely similar, and actually looking at it, it's almost exactly the same as the connector. So the top hat connector with lag bolts screwed into the top surface of the bearers that you will see on concrete. So it looks exactly the same as that. The reason that there have been issues with that on long concrete bearers is you're dealing with a very hard and brittle material that you're trying joined together. So there's very little, well, there's no resilience in the material. And so therefore, if you don't have exactly and perfect jointing of those two bearer faces together within that layout, and you've got the loads are being applied or bending moments being applied at that particular point, you tend to get wear of the concrete material at that point, and therefore you get degradation of performance. With a composite material, because it's a much more durable material, I mean, similar to timber, but a material that doesn't rot and degrade over time. The durability of that material has so far, I can say, we've only got only a few years worth of demonstration of this, but performs very well, and you don't see those issues around the material interface because the material itself won't degrade. We've already demonstrated over many years and many millions of cycles of testing that you don't get any shuffle of within the fixings. You don't get any elongation of fixing holes within the material. There is nothing to suggest that continued performance won't go on for the same length of time as the sleeper.
Okay,
and the other one, we do have a different. There's a different sort of system that we've used elsewhere. So we have a through bolted system, which is actually very effective for where there's limited space above and one wants to keep a nice tight profile on the sleepers, and where prefabrication before delivery to site is the desired approach. We have essentially a through bolted top hat system as well, which is a very effective long term solution, but less effective if you're trying to join bearers together on site. And for TFL regularly, it's a limit in envelope around the side of the track to be able to slide in an 8-meter bearer, and of course it's much easier to slide in 2-4 meters and join them in the middle.
Okay, thanks. Has there been any trials of this type of sleeper system on ballastless track without any ballast underneath, laying on a concrete base?
Yeah.
And how does that perform? Does that do well? I mean, I appreciate there would need to be a lateral. So
there's been a fair amount of work done on this actually, both in the US and in Italy actually. Milan use in their metro system use a lot of, they almost all slab track. And they actually they have been historically set timber sleepers into slab, and that has over the years presented them with significant challenges through degradation of the timber in those environments. And actually they installed some of our sleepers back, nearly 15 years ago now, in that track, using the same method they use for timber. So setting them in a sort of in a slab, both in pre-poured slab with slots left for sleepers, and in post-poured concrete set in and around the slab, around the sleepers in use, has worked very effectively. And in New York, they've done a tremendous amount of work with pit. They use a lot of pit blocks, so they call them stub sleepers in the track in the New York subway. And those have been, and they tend to be sort of post-poured, so they set into a slat and then pour concrete around them to do that, and that's worked very effectively. And actually, you'll notice in this picture of the cyclist sleeper, you can see these little sort of golf ball pattern down the side. We call it the dimple pattern. That's been developed to provide a lock-in with the ballast in the ballasted track to provide good lateral resistance in the track. But those also provide a very good key for post-poured concrete in slab track style of applications for that as well. So so there has been a lot of work done in this, and in S&C in the US. They have a number of rail lines that use that put S&C into slab, and what they find, the extra resilience offered by the composite sleepers in those environments has worked very well.
Yeah, that's great. Yeah, I mean, it also seems to me that there might be a noise and vibration mitigation benefit as well from these.
There is, and it's an interesting balance between, because there are so many variables in the noise and vibration in track. But certainly empirically, this has been seen, and we see it actually. You see the difference between the use of timber and when we've seen timber being replaced by concrete, particularly in the urban environment. We've seen an increase in noise and vibration complaints coming from that. and the composite sleeper performs in a very similar way to timber in track, but also can be tuned with the use of appropriate base plates to deliver even better performance. But it becomes that sort of system approach to doing things. So rather like looking at the bridging application and looking at things in a different way by combining fixing systems with the composite sleepers to deliver those benefits.
Yeah, okay, that's great. Can't see any more questions in the chat. Is there anybody who wants to ask a question that's not typed it in? No, I don't think so. So maybe it's a point to wrap up, and just to say a big thanks, William. It's a fantastic presentation, and so many applications. This is definitely the way forward in my mind, particularly not just the cost saving aspect, but the carbon emission aspect as well. I mean, that's such an important feature in today's railway construction, and you've shown some massive savings on carbon emissions there by using these type of sleepers. So it looks to me like it's got a massive future, and yeah, I think also it'd be interesting to see it being used on faster and faster speeds to see how it performs, even up to on high-speed railways as well.
That's certainly, Phil, the intent of of Network Rail, and Andrew Haynes has got a particular look at this. I wanted to see where he can push the envelope on this in those different applications. And I like it a bit to the golf bag piece, really, where there are you want all the right clubs for the different the different shots you're going to play on the golf course. Well, this is a similar sort of piece, really. If you're a track designer, you want a choice of all of the right tools to use for your particular piece of track design, and this just adds into that into that piece for you.
Yeah, I look forward to the day where we get track renewals where all the sleepers are, this type of product. That would be the big change. Yeah. Okay. Well, no, really interesting presentation, William, and thanks for coming along and spending time to present to us. It's much appreciated. So big round of thanks from myself and the Ashford section, and on behalf of everybody else that's joined today. Thanks for coming along.